Every summer feels hotter than the last. The ocean's boiling, wildfires are raging, and half the internet is screaming, "We're doomed." So, are we? Let's get real. Earth's temperature has risen by about 1.2 degrees Celsius since the late 1800s. That may not sound like much, but it's enough to melt glaciers, supercharge storms, and push ecosystems to the brink. And yeah, humans are the main reason. Burning coal, oil, and gas dumps billions of tons of CO2 into the atmosphere every year. Burning coal, oil, and gas dumps billions of tons of CO2 into the atmosphere every year, thickening the planet's heat-trapping blanket. But here's the good news. Physics got us into this mess, and physics can get us out. When we cut emissions, the concentration of greenhouse gases starts to level off. That means warming can slow down, not instantly, but within decades. We've already seen proof. When air travel dropped in 2020, pollution and CO2 briefly dipped, and the air literally got cleaner in weeks. Of course, we can't just stop everything forever. So scientists are developing tech to pull CO2 out of the air, giant fans that suck up carbon and store it underground, artificial trees that breathe like real ones, and algae farms that lock away carbon in the ocean. It's not sci-fi, it's happening right now. Still, none of that replaces the basics: renewable energy, efficient transport, smarter farming, and reforestation. Every ton of CO2 we don't release makes a difference. And while politicians argue, the planet keeps the score. If global warming hits 2 degrees Celsius, things get rough. More droughts, lost crops, flooded coasts. But if we stay closer to 1.5 degrees, we can avoid most of the worst outcomes. That's not fantasy, that's math. The future isn't set in stone, it's written in our emissions, and the sooner we change the story, the better the ending looks. So no, it's not game over. It's game on, and that's baby science for you. When scientists cloned a sheep named Dolly back in 1996, the world freaked out. Headlines screamed about human clones, armies of duplicates, and Frankenstein science. But cloning isn't as sci-fi or as scary as it sounds. Here's what actually happened. Researchers in Scotland took a single cell from an adult sheep's udder and inserted its DNA into an egg cell whose own nucleus had been removed. Then they gave it a little electric jolt, basically saying, "Hey, start dividing." And it worked. The embryo grew, developed, and eventually became Dolly, an exact genetic copy of the original sheep. But cloning isn't magic, it's cellular reprogramming. Scientists trick the mature cell into thinking it's a fresh, brand new one again, like wiping a phone back to factory settings. And it's hard. Out of 277 attempts, only one worked. Since then, we've cloned cats, dogs, cows, and even monkeys. So why not humans? Well, because cloning a person raises massive ethical and biological problems. It's not just copy and paste. Even identical DNA doesn't mean identical minds, memories, or personalities. A human clone wouldn't be a twin. They'd be a separate person with their own life and experiences. Plus, cloning still involves a lot of failures, mutations, and suffering in animal tests. That's why most countries have banned human cloning altogether. But here's the cool part. The same technology that made Dolly possible is now helping save endangered species. Scientists have cloned black-footed ferrets, Arctic wolves, and are even working to bring back the woolly mammoth. Yeah, real-life Jurassic Park, but hopefully with fewer people getting eaten. Cloning isn't about building armies of duplicates. It's about understanding life, restoring species, and maybe one day, curing diseases by regrowing tissues and organs. So no, we're not mass-producing humans anytime soon, but the science behind cloning, it's already changing our future. And that's baby science for you. Imagine this. A virus sneaks into your body, maybe from a sneeze on the subway or a doorknob at Starbucks. Before your immune system even has time to assemble the troops, one molecule sounds the alarm. Meet interferon, your body's built-in early warning system. When a cell gets infected, it doesn't go down quietly. It sends out a chemical distress signal, interferons, basically shouting, "Hey, neighbors, there's a virus in here. Lock your doors." Nearby cells hear the message and start producing antiviral defenses even before the virus reaches them. The name interferon comes from interfere, because that's exactly what it does. It interferes with the virus's ability to replicate. Think of it as the spam filter of your immune system, catching infected emails before they crash the whole server. But interferons don't just block viruses. They also call in the big guns, immune cells like natural killer cells and macrophages. Those guys show up, wipe out the infected cells, and clean up the mess. Here's the wild part. This entire response happens in hours, long before your body starts making antibodies. Without interferons, even a mild infection could spread like wildfire. Scientists have tried using interferons as medicine to treat hepatitis, multiple sclerosis, and even some cancers. They work, but not without side effects. Think fever, fatigue, and flu-like symptoms. That's your immune system in overdrive. Fun fact, some viruses, like SARS-CoV-2, actually evolved ways to block interferon production. That's part of why COVID could spread so easily before symptoms appeared. Your body is basically running a 24/7 cybersecurity system, constantly scanning for intruders and updating its firewall. You just don't get a notification every time it saves your life. So next time you shake off a cold without realizing it, thank your interferons. They are the unsung heroes of your immune system. And that's baby science for you. If you grew up on Star Trek, you've definitely imagined it. You step into a booth, someone yells "Energize," and boom, you're instantly across the galaxy. Sounds impossible, right? Well, not entirely. Scientists have already teleported things. Not people, but particles. Tiny ones like photons and atoms. And they didn't move through space. They used a mind-bending trick from quantum physics called entanglement. Here's how it works. When two particles become entangled, they're linked in such a way that whatever happens to one instantly affects the other, even if they're light years apart. Einstein called it spooky action at a distance, and he wasn't joking. Now, teleportation in physics doesn't mean the object literally flies through space. Instead, scientists transfer its quantum state, all the information describing that particle, to another one somewhere else. It's like sending the world's most complicated Snapchat, except the message deletes the original when it's sent. In 1997, researchers in Austria achieved the first quantum teleportation between two photons. Since then, scientists have done it over 60 miles of fiber optic cable and even between Earth and satellites orbiting in space. So yeah, teleportation is real, just not the sci-fi kind. But could we ever teleport a person? Not anytime soon. To transfer a single human, you'd have to record the position of every one of your roughly 100 trillion atoms, transmit that data, and then rebuild you perfectly on the other side. Oh, and the process destroys the original in the process. So technically, you wouldn't be moving, you'd be replaced. Kind of takes the fun out of it, huh? Still, quantum teleportation already powers the future of quantum computing and ultra-secure communication. Messages can be sent instantly and unhackably because any attempt to eavesdrop destroys the data itself. So no, you won't be teleporting to work anytime soon. But thanks to quantum weirdness, information already is. And someday, that might change everything. And that's baby science for you. You know that voice in your head that says don't start until it's perfect? Yeah. That voice might sound like motivation, but in reality, it's a trap. Perfectionism isn't just about high standards. It's the constant, exhausting belief that nothing you do is ever good enough. And while it might push you to succeed, it can also burn you out fast. Psychologists say perfectionism has two main types: healthy perfectionism, where you aim high but stay flexible; toxic perfectionism, where failure feels like the end of the world. The second one is brutal. It feeds anxiety, procrastination, and even depression. Because when good isn't good enough, you either overwork endlessly or don't start at all. Studies show perfectionists are more likely to struggle with insomnia, eating disorders, and burnout. One famous Harvard study even linked extreme perfectionism to higher rates of early mortality. Yeah, trying too hard to be flawless can literally kill you. So why do we do this to ourselves? A lot of it comes from fear. Fear of judgment, of not being loved, of losing control. Social media doesn't help either. Every scroll screams, everyone's crushing it but you. Spoiler alert, they're not. The brain releases dopamine when we get praise or validation, so perfectionism becomes addictive. You chase that hit of approval again and again until your entire self-worth depends on external results. But here's the thing. The opposite of perfection isn't failure, it's progress. The healthiest people aim high, but accept that mistakes are part of growth. Michelangelo didn't carve the David in one go. Edison failed hundreds of times before the light bulb worked. So, if you're stuck tweaking the same project for the 50th time, stop. Done is better than perfect. Progress beats paralysis every single time. Let go of flawless. Embrace finished. Because perfection isn't real, but learning is. And that's baby science for you.